So having walked through the functionality, I want to walk through the basic components of the case, since this is the part that requires the most redesign. So this here is version 1.0 of the case, which best represents the concept of the initial design. This is basically two halves here with a lip and groove, and these two fit together with compartments for all of the key parts, plus the front diffuser coupler. Right? So the diffuser coupler has threads in order to accommodate screwing in the diffuser blade on one end, and also holes on the other end to accommodate mounting the RGB LED. Right? Because the RGB LED contains a lens, and the lens here has a little hole, and that is where the LED will go, and then two mounting screws, M1.5 mounting screws, that this guy will allow clear. And so when I put the LED and snap it in here, the M1.5 mounting screws here are left visible. And these are the things that I will need to then go through these two holes in the back in order to create the lens assembly. And when assembling a newly printed handle, this is the first thing I need to do. I need to get this, I need to first kind of start the screws. These are very small, and so I'll need to put these screws in. Start that on that end, and I'll let it go down a bit because there's an air gap, right? When this is here, there's a gap here, so I want to be able to gauge where I have entered the Alright, and then I will put this guy through. And then fiddle with the alignment and then screw it in. Once it's screwed in, then, right, this will fit in here, and the light will hit the diffuser, and that's great. So how do we get this into the case? There's a slot in the front for it on both sides. It's a rounded slot designed to accommodate the round part of the coupler, plus we slot in here. And so I snap this in and push it down. Right, and you can see that it comes through to the bottom, and then the same thing will be true for the top. And then the cable, which will connect to the PC board, has a little chamber here, right? That's what this chamber clearance here is for, so that I can have some clearance for the cable, and also for cooling if I need it later. And this cable will fit into the receptacle on the PC board. Push that onto the PC board. Now the PC board rests on these four standoffs here. You see there's a ledge. And the PC board fits right into that. And I can push that down, and that should be an exact fit. And then the other side will sandwich the PC board down. And then there is the battery. Put the battery in. Now, these triangular parts here are designed to hold the battery. And so the width of this slot is designed to hold the 9-volt battery sideways like this. And then the height clearance between the pyramid at the top side is the correct amount to sandwich it at the top. And so I will hook up the battery. And then there's a particular way that you have to put the wire to the side so it clears and allows the battery to sit completely within the channel slot. And then we go on the top, and then there's the lip and groove, and then you kind of need to fiddle with it and squeeze it in, and then it'll hold on right now, basically based on the tension. You'll see that it comes through on the other end. And so this is the basic design, right? And then the coupler, right, sticks in here. Then there was the version 2 design. Version 2 design is very much like the version 1 with a couple of changes. The first one is gripping these corners, not so great. So I put some serious 14mm fillets in here. Because of the way that the CAD drawing is designed, I designed it with the profile of the bottom area. That means that I can't easily switch it to to change the profile here, because it's a bottom top extrusion to be completely round. In this case, this is just a big fillet on the bottom and the top all around, and a matching fillet on the coupler. So the coupler fits in. I'm not going to disassemble it like the previous version. The concept is the same. The coupler fits in, and everything else goes in the exact same way. However, there's a design flaw now that there's several different kinds of antennas, so I got to wind this antenna underneath here for now, and that'll be fine. All right. The design flaw is now that there's a fillet, the front part of the case is now structurally much weaker. And what that means is that when I put it together, you'll see already that one of the issues is that this front coupler sits kind of loose. And so when I put it together, and I'll just hold on to this, the coupler kind of shifts, and there's also a bunch of play here because this joint is weak. So I made another change, one that I just designed, and made two changes. The first is I thickened the front end here so this is stronger, and I also connected the bottom. And this makes the front, prevents the front part from flexing. It also, when the coupler fits in, you notice there's a notch here now, and the notch matches this part here. And so when I put the coupler in, snap this guy in, and when I push it down, when it snaps in, now the notch prevents the coupler from moving side to side, and the fact that there's a bridge now between the front will prevent flex from the front to back. I also took the top and I split it in two. And this may not actually be such a great idea because I'm having trouble having these two ends fit together. Same notch and groove. The idea is that this is the battery compartment, and so in theory I would be able to put this on, and then through whatever mechanism I use to hold it together, right? Remember, right now, just held together by tension. I might have to tape it together or something to keep it on. Maybe I could just pull it off. But it turns out that for 3D printing, I can only get a really precise overhang, the overhang necessary for this lip and groove, in one dimension. So I can either optimize for the overhang here, or I can optimize for the one here. And in this case, on this part, this overhang here prints out really poorly. I need a lot of filing, and it doesn't really fit. It fits extremely, extremely poorly. So that part needs a little bit more thought, maybe with enough slot that this could be made to work. It may be that there's nothing wrong with the design, I just need to change the way that I print this out. I did do something where, because of the shape of these overhangs, I printed this part on this orientation on the bed, and I printed this part in this orientation on the bed, just like everything else, right? Because I print the top part in this orientation too. And that means that the dimensions here are a little bit different since the features are on a different axis, and so the lip and groove on this side does not precisely match the lip and groove here. The right way to do this remains to be seen. I think that I can make this work somehow. This again is okay. The big problem here is still there's no clasping mechanism, and I'm left with these filleted. If I were to have this redesigned, I would like it done in a way perhaps where there's maybe a multi-start screw instead of this clamping mechanism to couple this onto a single part here. Maybe instead of having this be designed to have half of it open and closed, I could go back to a design somewhat like this. Perhaps retain the clamping thing. Maybe the front will be clamped, and then the back have some kind of screw mechanism. And maybe if there were threads out here, I could put a collar on this to hold this together. Then the whole thing would be pretty secure and also be entirely 3D printable. There are probably other better plastic design ideas out there as well for improving the design of this case. But this is an area where I need the most ideas. I'm not a plastic CAD designer, so I don't really know the standards, the design patterns for the design of plastic parts in Autodesk Inventor.